Hi friends, I'm Sudhanshu and I welcome you to this video. In this video, I have discussed Cisco Discovery Protocol, which is a Cisco proprietary protocol which is used to collect information about neighboring devices. In this video, you will learn about CDP concepts, how CDP works, CDP frame format, how you can configure and verify. So let's get started. If you have any difficulty understanding any topics during video, do share your questions in the comment section. So let's begin.
So the protocol that we are going to study is CDP and Lldp. These are two different protocols, but in a way quite related with each other. The main purpose of this protocol is that they have Cisco Discovery Protocol. Okay, actually, initially there was this protocol which was made, Cisco Discovery Protocol, and with Cisco Discovery Protocol, what they did was the main purpose was that if, let's say, you have a router and you have a switch and both are Cisco devices, you could see neighboring devices by going to the CLI of the switch. Let's say if you do show CDP neighbor, a command, then you will be able to see a router, which router model and all that. The benefit of having this kind of protocol is that if in case you are maybe performing some activity on your network and you're not completely sure whether maybe on fast Ethernet 0/1 I have this router R1 or not, you can double check that quickly by doing a show CDP neighbor and see if you see the host name of R1 being reflected there, you can be more confident in doing the configuration. So initially Cisco made this protocol, which is called Cisco Discovery Protocol. And later on, when other vendors also felt the need of similar standard-based protocol, because this is a proprietary protocol. So this does not work in non-Cisco devices. In fact, even the VMware, they borrowed, they licensed this protocol for their VMware servers. But still they wanted to make something standard-based protocol. So that is when link layer discovery protocol was created. And the purpose and working is same. Okay, so a lot of things that I'll be discussing in CDP will be applicable for Lldp as well. Okay, we will be discussing even stuff where they are different. So let's begin. CDP, Cisco Discovery Protocol, like I told you, it discovers the basic information about the neighboring routers, switches, without needing to know the passwords for the neighboring devices. You can get to know their host name. You can get to know even information about their operating system if you issue the show CDP neighbors command. And to discover this, they periodically send each other. Let's say I have two routers here connected with each other. Then this router will be sending a CDP message. And similarly, this router will also be sending a CDP message to the other router. That way, this periodic CDP message is what indicates to this router that there is somebody with host name R2 that is here. And similar way, R2 also knows about R1. So these messages are in a way announcing this, that this device like R2 with this iOS, and even in certain cases, you will see IP address information about those devices here. So this all is carried in that message. Now, the common fields that are carried, one is a device identifier, and typically this is the host name of the device. So every networking device has a host name. So that is carried in this message. Apart from that, sometimes the network and data link addresses, these are covered, these are carried. Port identifier, this tells the interface on the remote router or switch. So basically, let's say R1 here is connected on fast Ethernet 0/1 to fast Ethernet 0/0 of R2, then R1 will be informing in the CDP message to R2 that I have a connection with you on fast Ethernet 0/1 interface. Okay, so when you do this, this is the port identifier part. Apart from that, it also advertises something like what are the capabilities in this device, whether there's a routing capability, whether there's a switching capability. So these kind of devices capability are carried to the other side. In fact, if you use a Cisco IP phone, so that information, that Cisco IP phone also supplies and exchanges this CDP messages with a switch. So it also informs the capabilities like I'm a phone. Okay, then there is platform. Platform tells the model and the operating system level running on that device. So this is the basic information about CDP. Now, I already told you the uses. There are two main roles that CDP is going to provide. Okay. Now, since I discussed Cisco IP phones, okay, let me tell you what happens with Cisco IP phones is there is an information that Cisco IP phones ask a switch with which they are connected. So when this phone comes up, it will send messages of CDP to this switch. And it will ask for information about VLAN. To be more precise, information about voice VLAN. Now, what is voice VLAN? It's a special VLAN that we configure for in the switch configuration for IP phones. So how will a switch know what voice VLAN information to supply to the phone? That is based on the configuration by admin in the switch. Okay, so don't worry too much about the VLAN part. Okay, so we will discuss this later some other day. So first function that I'm telling you is with Cisco IP phone asking for voice VLAN information and switch supplying this voice VLAN information to the IP phone. So this is the first function, to provide information to the devices to support some function. So IP phones use CDP to learn data and voice VLAN IDs. The second function that we have is related to the device management. Like I was telling you that these devices, let's say switch 1 has a connectivity with switch 2, or maybe another router R1, then switch 1 can detect that there is R1 connected on fast Ethernet, whichever interface. So that is the second function of CDP, to provide information to the network engineers that manage the devices. And we can issue some show commands that will list information about the neighboring devices. So we can use the show CDP neighbors command. Commonly, this is the most used CDP command to check which all devices exist on any particular interface. Now, you can also issue a command of show CDP neighbors detail. This will give you a little bit more detailed information about individual devices. Or else there is a third command of show CDP entry, and then you can mention a particular name of a neighbor. Then it will display only information about that particular neighbor. Okay. So let's say if we have this topology. In this topology, if I go to switch 2, and if I issue the command of show CDP neighbors, you will see something like first, these are the capabilities. R means router, S means switch. And you can see here that on R1, it's showing the capabilities of routing as well as switching. On this other device, that is switch 1, connected on gig 1/0/21, it shows you that it just has switching capabilities. Now, there is this I, which tells capabilities related to IGMP, which is used for multicast, but that is not too relevant right now. So I'll not go into that. And apart from that, you can see that we have the local interface information like switch 2 knows that this interface gig 1/0/2 has a device connected to it. But along with that, it also has information about some of the other interfaces. So like it knows that from R1's side, the interface is gig 0/0/1. So it is the remote port ID that also is informed to the switch 2. This is informed by R1 when it sends CDP messages to switch 2. Similarly, it knows that switch 2 is connected to switch 1 on gig 1/0/24. It also knows about the platform. So which switch model, which router model, that information is also told by show CDP neighbors. So you can guess that there's a significant amount of information that is displayed with this CDP. Now, this is CDP. This CDP is a layer 2 protocol. Now, what do I mean by that? Now, commonly students there have a question that, okay, fine. If I go to switch 1 and do show CDP neighbors command, what will be shown? Then switch 1 will only be able to see switch 2. It will not see any information about R1 because R1 is not directly connected in any way with switch 1. So CDP shows you information only about those devices which are directly connected with you. Okay. Now question comes, why only direct neighbors are shown by CDP? And in order to understand this, we have to take in account the statement that I made earlier that CDP is a layer 2 protocol. Okay. Now, what do I mean by that? What we mean is that CDP, whenever you have any CDP message, if I show you layer by layer, it contains a layer 2 header and a trailer. That's it. There is no IP header, there is no TCP, UDP, anything working. Now I'm taking Ethernet as an example here, but it could be even for other layer 2 protocols. So what happens in this case is whenever you want to send a CDP message, let's say switch 2, or let's say R1 sends a CDP message to switch 2. In this case, there will be a data link header, that is a layer 2 header, but there will be no IP header. So like I told you that CDP defines encapsulation that uses the data link header, but no IP header. Now, apart from that, it also uses a multicast MAC address. So there is a multicast MAC address of 01000 CCCCC and then 4 more C's. So this is the destination MAC address that R1 will use in the header of Ethernet, okay, and send this message to the other side. Now, when switch 2 receives this, it will decapsulate this. It will remove this header and trailer, look at the CDP message, and populate the information in the CDP neighbor table here, which we saw here. Okay. Once it does that, once switch 2 has populated this information in the neighboring table, CDP neighboring table, then it discards the message. It cannot forward it further. Why? There is no IP header, there is no routing that can be done for these messages. So when any device that supports CDP receives a CDP message, the device processes the message and then discards it rather than forwarding it. So this answers the question like why only direct neighbors are shown by CDP. Okay. Now, If we issue a command of show CDP neighbors detail, the same switch 2 is going to show you a little bit of more details, like what is the IP address of the switch 1, which is having this platform, which is having switching capability and IGMP capabilities. So a little bit of more detailed information. It also contains information about the iOS version that that particular switch is running. Okay, so there are some other output, obviously, because switch 2 has two neighbors. One is switch 1, another one is R1. So after this information, there will be further information where it will include information about R1, its capabilities of router, switch, IGMP, whatever platform it is, and also some of the iOS software related version information. Okay. So further, if we have to configure CDP, okay. Now the good thing about CDP is it is working by default. So let's say if I open Packet Tracer, okay, let me open a brand new topology here. Now I'm using switches here. Okay, so you can use a router. Okay, these things don't matter. Why I'm using a switch here is so that I don't have to no shut the interface. Switch interfaces are by default up, and I will keep a router here as well. Let's say this one. So let me connect these up, and I'm just randomly connecting them. And on router, I will go and just bring this interface up, because bringing the interface is important. Then only these CDP messages will go back and forth between the switch 1 and router 0. So I'm not configuring any IP address on this interface. Okay, just bringing it up, no shut. And all of these other interfaces will be up by default because switches have the interface no shut by default. So now if I one of the good things about CDP is it's working by default. Okay, so did I give any command of CDP here? No. Still it is working. So if I go and exit, let's say if I do show CDP neighbors on this router, you see that there is this switch which is connected on local interface of gig 0/0/0. Okay, and the remote side, that is the switch 1 side interface, is fastconnect 0/2. Now the reason why it is showing the name here as switch is because we didn't even configure any host names on any of the devices here. So that is why you see it this way. I will configure the host names. Let me even configure a host name for this router so that it's completely clear. Let's quickly configure the host names on all the switches. Switch 1. And I'm still not configuring any CDP related stuff. I am configuring the host names just so that we can be very clear on what device is connected where. So switch 2. This one. Let's call it switch 0. Okay, so if I go to, let's say, R0 now, and if I issue the command of show CDP neighbors, now you see this switch 1 entry. Now you see 2 entries here. The reason for that is there is this older entry of with the host name of switch, which is already there. It will not stay here forever. It will go after some time, that is hold time. It actually kind of counts down this time. So after some time, when the whole time reaches 0, this entry will be removed from this CDP neighbor table. So we can see that switch 1 entry already here. So every few seconds, they send this CDP messages. There are timers related to this. We'll discuss that. Let's check the other switches out as well. So let's go to switch 2 here. If I do a show CDP neighbors here on switch 2, what you see is again 2 entries which will be gone after like 49 seconds and 85 seconds. This is second based countdown that it is doing. And you can see that on switch 2, we have fast Ethernet 0/1, the local interface, and even the remote interface is 0/1. On switch 0, we have it on fast Ethernet 0/2 here, and the remote side is 0/1. Okay. So I think they should be gone. Okay, it's almost over. The whole time is almost over. 5, 4, 3, 2, 1, 0. And you can see now that entry is gone. Similarly, this entry will also go away. So why do we need not to configure any CDP related things is because by default, there is a command here that is already there, and that is CDP run. So it is there by default. We don't need to enable CDP. But if we do a no version of this command, we can disable the CDP. So if we do no CDP run, that will disable Cisco Discovery Protocol. Now, will this thing lead to immediately getting all these entries removed? Let's check that. Okay, if we do show CDP neighbors, you can see CDP is not enabled. So it's very easy to figure out if CDP is not running. Why do people sometimes disable this? Like I told you that CDP reveals a lot of information, right? Information about device models, iOS versions. So sometimes people and network engineers, for security reasons, don't like to keep CDP running unnecessarily. This is especially true for switches because these are generally connected directly to the end user devices. So some attacker can use a packet sniffing software to gather this information, to gather information about what kind of devices you are using in the network. So sometimes people like to disable the CDP. So if you do this no CDP run, you have disabled it for the whole switch. If you want to do it on a per interface basis, then you can go into an interface fastnet 0/2, and there you have the command of CDP enable, which is by default there. If you do no CDP enable, you disable the CDP on that particular interface. So this case, you may this command you may give on those interfaces which are connected to end user hosts, and you don't want to unnecessarily reveal the information about your device. Okay, so if you want to be selective per interface basis, you can do it this way. If you want to be disabling it for the whole switch, then you can do it this way. So let me enable it back. Let's go ahead from the slides. And like I told you that iOS typically enables CDP globally on every interface by default. You can disable it on a per interface basis by doing no CDP enable, or you can re-enable it by doing CDP enable. To disable CDP globally, no CDP run to enable it. For regarding the timers, by default, every 60 seconds, they will be sending messages of CDP to the other side. And they have a hold time of 180 seconds. That means if in case, like I was showing you that, let's say I disable CDP, or maybe I change some parameters here. This entry if there is no CDP message received for 180 seconds, switch will remove this entry from the CDP neighbor table. Okay. So the hold time tells how long to wait after no longer hearing from a device before removing those details from the CDP table. Okay. So you can override these timers by giving the CDP timer command. I'm not sure whether this is supported on packet tracer or not. Let's double check. So CDP, okay, like I told you, okay, you cannot. But this works in a real switch or router. So CDP timer command can be given in that case, and you can give CDP hold time, and that will decide the hold time. Okay. CDP timer decides how frequently the CDP messages should be sent. So if you do show CDP, you can see that information about timers, 60 seconds, 180 seconds. And if you do show CDP interface and a particular interface name, you see how frequently they are being sent on that interface. It also shows you show CDP traffic, which shows you how many packets sent and received. Okay. So that is CDP.